packaging. Bottling is divided into dry and wet sections. The dry section includes taking off pallets, unpacking bottles, and cleaning crates, repacking bottles and putting on pallets. Hardly any measurement devices are used in this area. An exception is the crate washer. The overflow of the main liquor from the bottle washing machine is used to clean the crates. It is supplied with liquid media and uses temperature regulation as well as level switches and underfill detection. Also, the respective spray pressure is measured at the nozzles. The filling plant is cleaned with its own CIP equipment. A Smartec S CLS 132 is also used here for conductivity measurement and therefore to determine concentration and phase separation. The level in the tanks is measured hydrostatically with DB50 sensors. The bottle cleaning machine is the largest machine in the brewery. It uses the most energy. The bottles are treated in different soaking baths and spraying areas. This is done with different caustics concentration. They are rinsed with fresh water at the end of the process. Various switches are installed, above all the pressure and temperature switches, in order to protect the pumps, which ensure that in each bath the right conditions are present. A cleaning machine has up to 3 baths and 7 spray zones. In order to ensure the alkaline concentration, the conductivity and redox potential are measured. At the same time, chlorine and pH are measured. The alkali concentration is monitored with Smartec conductivity sensors. Here is movement by the sensors. As you see, the machine is vibrating and moving, even if it is very big. The cleaning machines at the Rothaus Brauerei work according to the double-end principle. The bottles are fed in one side, cleaned and then discharged on the clean side. This achieves good separation between the clean dry and dirty wet areas. The level of the baths is regulated both by a pressure switch and via liquefants. The fresh water supply and the chloride dosing is measured and regulated with the Promag P EMF. The mechanical pressure sensor shows the varying pressures depending on whether the fresh water supply is on or off. One can well see the sorter path in the bottle conveyor, the amount of vibrations that can occur in a brewery through pumping or rotating drives. This is not only limited in the bottling machines, as this situation can also occur in pipelines and the requisite force can also penetrate into the sensors. After the bottling machine, all bottles are completely optically checked. If there are irregularities, the irregular bottles are put on the sorter path. The bottles are filled and capped in the filler. In order to prevent contact with oxygen, the bottles are first rinsed with CO2 and biased. The closed bottles then come to the capsuling machine. In the Rothaus brewery, the gold foil is set on them. Then they are brought to the labeling machine, which puts on the paper labels and prints the date of expiration. This labeling machine usually has no significant measuring devices up to the glue temperature sensor. Most measuring devices are found in the filler inlet valve nodes. The control screen gives rough information where measurements are being taken. Outside the valve nodes, a few sensors are directly mounted on the filler vessel. In the inlet nodes we find, among other things, an Obisphere oxygen meter and a Sensotec Liquisonic measurement for the density measurement and extract determination. A Smartec CLD 134 is installed for water beer phase separation. In addition, Cerebar M is used for the filler pre-pressure and CO2 control pressure to the filler tank, as well as omnigrade temperature sensors for the beer. and a SensiFlow mass flow meter to determine CO2 needs. Each line which goes to and from the filler is monitored for temperature and pressure. The bottles are subjected to a vacuum in order to suck out the oxygen. The vacuum pump is fitted with a shaft water tank. This tank is equipped with a liquefant in order to prevent the shaft water being too low, as well as with a temperature regulator. In the keg equipment, the empty barrels are automatically stacked and turned in the correct orientation. Afterwards, the remaining pressure is checked. If there is no remaining pressure, it is assumed that the keg is either damaged or is manually opened, and therefore something could be contained which could impact the quality of the beer. These barrels are manually assessed. All kegs which are assessed as good are turned, cleaned on the outside and brought to the cleaning and filling station. The supply of the equipment with various media is done from external tanks. The cleaning material tanks can be seen well here, which apply vibration to the lines when valves are opened and closed. The keg's cleaning and filling machines consist of several stations at which the barrel is filled with alkali, then soaked, then completely emptied. They are cleaned a second time with alkali, then rinsed with water, neutralized with acid, and then filled. The filling itself is checked with electromagnetic flow measurement devices made by the Dissel company. In the beer inlet, oxygen measurement is done by a device made by Orbisphere, and extract measurement is done by a device supplied by the Sensotec company. In order to check the cleaning activity of the keg's equipment, so-called test barrels are used. These are equipped with a glass which ensures that all areas are wetted. At the same time, pressure and temperature are measured. Wastewater treatment. The brewery's own wastewater treatment facility is below ground on the company's property. A part of the electricity necessary for the brewery is produced by water power, using the level difference. The wastewater treatment facility can treat an equivalent amount of water to that required for 90,000 to